So the first thing we do when we're solving a system of three variables is we pick two equations. In this case, I'll just pick the top two for no good reason, just because we need to start with two, and we eliminate one single variable. So if I pick these two, none of them will eliminate right away. However, 2 is a factor of 4, so I might choose to multiply everything in this equation by -2. So that it'll eliminate with the 4x. So I'm just going to label these equations 1, 2, and 3. Okay, so I'm going to start with equations 1 and 2. So equation 1 is fine as is. And I'm going to multiply everything in equation 2 by -2, so that I have -4x plus 6y minus 10z equals a positive 14. And I'm going to eliminate my x terms here. When I add up the remaining terms, I have 8y minus 7z equals 26. I'm just going to hang on to that for now. Now what I'm going to do is pick a different combination of two equations and eliminate the same variable, the x term. So I've already used 1 and 2, so obviously I have to reuse one of them again. It doesn't matter which one. What I'll probably do is, because 2 is a factor of 6, again I'll choose this equation, multiply everything by -3, and then keep number 3 as is. So here I'm going to choose equation 2 and equation 3. So if I multiply everything here by -3, I have -6x plus 9y minus 15z equals a positive 21, and then 3 I like as is, 6x minus y plus 4z is -3. So again, my x's cancel. I wanted that to happen. I needed that to happen for this to work. And I'm left with 8y minus 11z equals positive 18. So now what I have is two equations in two variables, and I know how to solve a system of two. So I'm going to, from here, sort of pick up what we know, where we would be starting a system of two, okay? So these both have coefficients of 8. I'm just going to go ahead and multiply one of them by a -1 so that they eliminate. So I have 8y minus 7z equals 26, and here I'm going to put my minus 8y plus 11z equals -18. And eliminate the y's. I'm now left with 4z equals 8. And if I divide both sides by 4, I have z is 2. So I've solved my first variable. From here I need to solve for my second variable by plugging this back into either this system of 2 or this system of 2. It really doesn't matter which one. I'll choose this one just because it's closer. So I'm going to take this new equation here, or I'm sorry, the system of 2 here, 8y minus 11z is 18. Plug the 2 in for the z, and simplify. And I think I've just gone off the paper. Let me slide this down. And here we have 40. Therefore, y is 5. So now I have a solution for z and a solution for y. What I'm going to do is I'm going to bring these guys both over here, and I'm going to plug them back into one of my original systems of 3. It doesn't matter which one I pick. Again, I'll just pick number 1. And I have 4x plus 2y plus 3z is 12. I don't know the value of x, so that's my variable. The value of y was 5. And the value of z was 2. So I have 4x plus 10 plus 6 equals 12. 4x plus 16 is 12. 4x is -4, therefore x is -1. So now I have a solution for x, y, and z. Just to be sure that I haven't made a mistake, because it's very easy to make a mistake with all of this computation, I'm not going to pick equation 1 again because I used it to solve for x, but I'll pick one of the other two equations to check. So if I pick equation 2 to check, it's going to look like this. So equation 2 says 2x minus 3y plus 5z equals negative 7. As you can see, each one of these problems can easily take up half a sheet to a full sheet of paper. So here I have 2 times negative 1 minus 3 times 5 plus 5 times 2 equals negative 7. And then I'm just using the order of operations here to simplify. Negative 2 minus 15 plus 10. This gives me negative 17. And this is where we know it's going to work because negative 7 does equal negative 7. So that's a good check. So this is the student attempt problem or the student practice problem. A couple things. You should all take a few minutes to try this before watching the video. But even before doing that, what I'd like you to do is reduce all of these equations. So B block, we did this in class yesterday. So what we're doing here is we're looking at all of these coefficients here being multiples of 2 or having a GCF of 2. Here as well. Here they actually have a GCF of 4. So what I'll do is I'll simplify these and then we can do the next step. So at this point, you should have these 3 equations, and we're going to work with these. Now, when we do the final check, we'll test it in one of these just to be sure. But these coefficients are going to be a lot easier to work with. So just like before, we're going to start with 2 equations. And if I'm just looking at the coefficients here, this 375 might be a little more challenging to deal with initially. Kind of like this 246 because we can multiply this by a 3 to eliminate with the 6 and by a 2 to eliminate with the 4. So that one might be less work. So let's do that. Let's eliminate the y. So if I start with the first 2 equations, we said we would do 1 and 3 and 2 and 3. So let's start with 1 and 3. Here we have 3x plus 4y minus 3z is 31. And I'm going to go ahead and multiply everything in this third equation by 2. So that my coefficient on the y term is a negative 4. So I'm going to have, 6x minus 4y plus 10z is a negative 34. And now I'm going to go ahead and eliminate my y terms, which leaves me with 9x plus 7z equals a negative 3. Okay, so there's one of my systems of 2 that I need to solve the system of 3. And then over here, I'm going to eliminate the y's again, but this time rather than 1 and 3, do it from equations 2 and 3. So there's always 3 options for this, but you only have to pick 2. So in this case, I'm going to keep equation 2 as is, and I'm going to multiply everything in the third equation by a negative 3 because I want this to read positive 6. So I will have negative 9x plus 6y minus 15z equals 17 times 3, and negative times a negative is a positive 51. And again, my y terms eliminate, and I'm left with negative 4x minus, they're both negative, so that's minus a 22z equals 58. And I'm noticing that these are again all evens. So one thing I can do is divide everything here by 2 just to clean this up a little bit. And I would have negative 2x minus 11z equals half of 58 is 29. Okay, so now I want to eliminate these 2 equations. None of my coefficients are real pretty, so what I might do is maybe eliminate the x by multiplying everything here. Let's see, the least common multiple of 2 and 9 is going to be 18. So if I multiply everything here by 9 and everything here by 2, then I will have those coefficients of 18 and negative 18. So this guy first, we have 18x plus 14z is negative 6. And then this guy we have negative 18x minus 99z. Can you imagine how big these numbers would be if we hadn't simplified them up there? Equals 29 times 9 is, it's okay if you need to do this out, I often do. It's 81, 18, and 8 is 26, 261. Okay, so these guys are gone. And if I add these up, I'm going to have a negative 85z equals, this is going to be a positive 255. Okay. So you might not see that 85 goes into 255, but it does. It actually goes in 3 times. So if I divide both sides by a negative 85, I get z equals negative 3. And I can sort of show that to you just by doing a little calculation over here. There we go. So z is negative 3. Okay, all this work just to solve for one variable. But from here, the rest of it goes pretty quickly, or at least a lot more quickly. I'm going to choose to sub into this equation. Actually, I don't even have to do that. I can choose to sub into this equation, so the simplified version of one of those, okay? So if I have negative 2x minus 11z is 29, then I can plug in my negative 3 for the z and simplify. And I've run off the paper again. Sorry about that. I'm very low tech here, so let's see. Negative 2x is a negative 4. Divide both sides by negative 2, and I get x is 2. All right, so now I've got a z, an x, and I'm going to plug into an original equation to solve for y. So I'm still going to pick one of my sort of simplified versions here because I can. So I'm going to pick that first equation. 3x plus 4y minus 3z is 31. Replacing x with 2. I don't know why. I don't know the variable y. Replace z with negative 3. So 6 plus 4y plus 9 is 31. That's 4y plus 15 is 31. So 4y is 16 and y is 4. Okay, so now I have answers for all 3 variables. And I'm going to have to now just double check by plugging all these into one of the original equations. And at this point, I do want to pick an actual original equation, just to be sure. Now, when I just solved for y, I used this equation, which was derived from this one. So it really would behoove me to choose one of these 2 equations. I'm going to pick this guy here to check. Okay, so that second original equation is 10x minus 12y minus 14z is 14. I'm going to plug in the 2 for x, I'm going to plug in the 4 for y, and I'm going to plug in the negative 3 for z. I always do this, minus 48. And now I'm just simplifying, using the order of operations. 20 minus 48 is negative 28. And 42 minus 28 is 14. So that checks. They all check. So that feels good. So we know the solution here. X is 2, y is 4, z is negative 3.